Hello friends, I am Haresh Suthar. So today we'll understand another instrument which is function generator. Now here you can see it's a Metravi make model FG-5000 and it is written it is 5 megahertz. So we'll first try to understand the functionality of all the switches and we'll try to understand the functionality of the knobs over here, that is a frequency knob and amplitude knob. So basically the switches are divided into power switches, then range, functions and attenuation. So we'll first switch on the instrument. So initially you should switch on the machine and you should switch on for 15 minutes for a warm up this machine, and then you should take in use. Now here as it is written that is a 5 megahertz, that means it can generate the waveform, or it can output a waveform up to 5 megahertz frequency. So basically, as we are aware that the name of the function generator means it is used to generate a different waveform, and which can be given as a test input to any of the circuitry or for any of the application. Now here the minimum frequency is 5 hertz and maximum is 5 megahertz. Now this is output port wherein it is connected with the BNC connector, and it's a 50 ohms resistance of this BNC port. Now this amplitude is for voltage being generated for that particular signal. Now here we have a three options, means this is sine wave, square wave and ramp wave. So using this alternate switches we can generate sine, square and ramp signals, and the amplitude of that can be adjusted from this knob. Now the frequencies can be adjusted from this frequency range switches. So here you can see that it's a X50, 500, 5K, 50K, 500K and 5 mega ohms. Now if you see on the display, then the unit is written in terms of kilohertz. That means whatever is the value over here should be assumed as a kilohertz frequency. So right now it is showing us something around 0.39 or something is there, right? 0.38. So we have to assume it as a 0.29 or 0.25 kilohertz. So that is nothing but 250 hertz. So here let's say we want to adjust some particular frequency, and that is, let's say, 150 hertz. So I have to select that range of the frequency, because 500 falls under 150. So now this is in kilohertz, so this is 0.101, that means it's a 101 hertz. Now how do we adjust the frequency? So the basic thumb rule says that you should now this is a minimum position and this is a maximum position of this knob. So this is for fine tuning and this is for coarse tuning. Coarse means maximum variation will be there in the adjustment. Now in this case you first adjust this knob in the middle position, and using coarse tuning you bring the desired frequency as close as possible. So let's say here in this case it's a 150. Now by default I am able to adjust the 150, but it's, let's say, 151. Then I'll try to slightly reduce the frequency by reducing the knob. So it's a 150, right? So it's a 0.150 kilohertz, so it's a 150 hertz. So similarly, depending upon the range, now this is for 5K, means you can adjust up to 5 kilohertz. This is for 50K, so you can go up to 50 kilohertz. likewise you can select the switches, and you can let's say adjust the frequency in terms of up to 5 megahertz. Now here there is a voltage output will be corresponding to the waveform will be there. So the maximum voltage output which can be possible with the 50 ohms load matching is 10 volt. Now there is a attenuation switch is there. Now here it is written it's a minus 20 dB attenuation. Now what do you mean by that? So here if you press this thing, then the frequency will not change, but only change will be there in the amplitude of the voltage. Now in terms of decibel, it is nothing but it will reduce the amplitude by 10. 20 dB means it will reduce the amplitude by 10. So it's nothing but in terms of the formula 20 log 10 formula, if base is 10 and 20 log 10 raised to 10, then it's a minus 20 will be there. So based on that you can say that it will reduce by 10. So let's say the amplitude adjusted is 5 volt. Now in that case the actual output amplitude from this output knob will be 0.5 when this attenuation is being pressed. If you remove the attenuation, then the output will be let's say 5 volt, and if you press this attenuation, then it will be reduced by 1/10. So whatever is the amplitude you will have, and if you press this switch, then it will be reduced by 10 by the factor of 10. Now the another important point which I would like to discuss is regarding the variation in the frequencies which are there in the the instrument is showing on the display, and actually you will get on the at the output of the waveform. So the variation is about 2%. So it may happen that let's say 2% means in a range of 20 hertz to 20 kilohertz. So in a simplistic language, if I'll say that if it is 100 hertz is a frequency which is adjusted over here, then there might be a possibility that it may be 98 or it may be 102. So likewise you can calculate that 2% is for 20 hertz to 20 kilohertz, but as frequency increases above 20 kilohertz, then the error may be up to 2 to 3%. Now when you press this switch, that is for a square wave, then in that case there is a rise time from 0 to maximum in a square. So it is less than 40 nanosecond. So as low as desirable, so quick change is desirable, so it is less than 40 nanosecond, and the total power consumption of the instrument is 20 watt. So this is what a functionality from the front end of the instrument. Now we'll try to see from the back end. We'll remove this power cord and we'll turn this instrument back. Now if you see over here, then here we have connected our power cord, and this is at here. If you remove using a screwdriver, then there is a fuse over here. So the fuse is of 200 milliampere. So by chance if you encounter a problem that instrument is not switching, when you even if you press the switch on button, power on button, and display is not working, or you are not getting output from the output port, now in that case the first the diagnosis begins from the power supply, that whether the instrument is receiving the power supply or not. So you have to first ensure that the power cord is connected or not. Then second is you have to check the fuse over here, that fuse is working, fuse is there or not, whether it has blown or not, or it's working fine. So the first step is this one, and second step of diagnosis is you have to check that this connection is proper or not. with a BNC connector. So these two are the first two steps of diagnosis when you deal with this instrument. So this instrument will use in the next explanation of the DSO, wherein we'll take the output from this machine and will give as input to the DSO. Thank you.